Do you want your Godot game to feel more immersive? Do you want your players to feel panic as they have to manually pull open doors when running from enemies, similar to games like Amnesia, instead of just pressing a basic interact button? Do you want more captivating puzzle solving where the player needs to manually flip switches or spin wheels, similar to games like Five Nights at Freddy's Secret of the Mimic? Then this is the right tutorial for you. I will walk you through setting up a robust yet very flexible interaction system that will allow you to create an immersive game where the player has to manually perform various actions such as picking up random objects in the environment, possibly throwing them around, pushing or pulling their mouse forward or backward to open doors or flip switches, or even forcing the player to spin their mouse in a circle to turn a wheel or a valve. This basic interaction system will be easy to build on and allow you to customize the actions that your players can do to make your game more fun and unique. Let's get started. So to get started, the first thing we're going to do is we are going to bring in an asset pack, and that is just some prototype textures provided by Kenny. Now, these are completely 110% free. I'll leave a link in the description below for you to use them as well, but I'm just going to drag and drop them into our scene, and that way we can change the color of the various objects that we're going to be tinkering with. We're also going to want to set up a little sandbox environment for our player to walk around in. So let's go ahead and do that now. So I'm going to do a new 3D scene. I'm going to rename this to sandbox as the root node. I'm going to add a CSG box, and I'm going to go ahead and drag it holding control up. Actually, I'm not. I'm going to hold down shift and bring it up 0.5, and that way it's sitting right level with the ground. I'm going to change its size so that way it's 30 meters on the X and 30 meters on the Z. And here we have a little floor. And just so it's not blank white like everything else in the game, we're going to go ahead and use our prototype textures. I'm going to choose the dark texture 13 and drag that onto the material slot. Now you can see these textures are meant to represent 1 meter, but this is 30 by 30, so we're going to want to change that. So let's go into our material UV1 and set it to triplanar, which means that when we zoom in, you can see that each square is now a meter. And we're going to rename that to the floor. All right, now that that's done, let's add some more CSG boxes. And this one is going to be a wall. And this is just so we can test a few things, one being basic collision. Let's go ahead and drag that up so that way it is flat with the surface. I'm going to make this 10 meters wide on the Z-axis and 3 meters tall on the Y. I have to drag it up again, but that's okay. And move that over, let's say right about there. And I'm going to go ahead and do the same thing and just drag the texture onto the material and make sure that it's triplanar. All right, so let's go ahead and add one more CSG box here. We want to pull it up so that way it's level with the floor. And then we're going to want to hold control and pull that up one more. We can go ahead and stretch that up to 2 meters and just kind of make it a little wider, something like that. And we'll drag that over there. Now we want this 1 meter off the ground because we want to be able to build a player that can crouch under this, but not standing walk through it. And so essentially, and we'll even rename it this will be our crouch check. And I think I am also going to add a texture on this, but we'll make it the light texture 13, triplanar, and you can see there's a little outline. Not a huge deal, but now we have an environment where we can ensure that our player can run, jump, sprint, and crouch. So let's move on to our player. Actually, before we move on to our player, let's go ahead and save this, but I don't want it to just save anywhere. I want to go ahead and create a folder that I am going to call levels, and now we'll hit Control S, and under levels, we'll call this our sandbox. So there it is. So now we can go ahead and get started on our player. So let's go ahead and create a folder for our player. We will just call this the player folder for the sake of this tutorial. We'll go ahead and create a new scene, and this is going to be a 3D scene. Now this is going to be a character body, so I'm going to change the type to a character body 3D. And as you can see, we get a little warning, but we will get that all sorted out. Now I'm going to go rather quickly here, but let's go ahead and rename this to the player node. And let's talk about what we are going to need for the player. Now, we are going to need two things. Right off the bat, we're going to need a collision shape while the player is standing and a collision shape for the player that is crouching. And to do that, we're going to hit Control A. We're going to create a collision shape 3D. We're going to rename this one to the standing collision shape. And we're going to go ahead and give that shape of a capsule shape. So it's going to be a bean. We're going to hold control and drag up so that way it is sitting on the floor like that. And there's our character. Now we're also going to need a collision shape for when the player is crouching. So we are going to add another collision shape 3D. We will call this the crouching collision shape. This one is also going to be a bean, but this one is going to be half the size. So click on the capsule shape, and instead of the height being 2 meters, make it a height of 1 meters and pull it up. I think I can just shift up to 0.5 meters high. So as you can see, we have a bean, and then we have a little sphere within that bean, and these are going to represent our collision shapes. So let's go ahead and get a camera set up for the player, but I'm going to add a few things in between. So on the player, we're going to hit Control A, and we're going to add a node 3D. On that node 3D, we're going to do the exact same and add another node 3D. And on that one is where we are going to add our camera. So this first node, we're going to rename to be our head. And this node under it, we're going to reset to be named our eyes. We are also going to take our head node and we're going to drag it, or better yet, set its transform to about 1.8 meters, which, as you can see, is right about where the head would be on our bean character. Now, the reason we're doing a head and an eyes node before the camera 3D is that the camera 3D here, we could control the y-axis movement and the x-axis movement, but we don't want to do that. As a character, we want our y-axis for our camera to be controlled by the way the player is looking. And the way the player is looking, we want to move the whole player body. We don't just want to move the camera, right? So we build the head to handle the x-axis movement, which will handle looking up and looking down. And then we are going to have the eyes. And the eyes are going to be a little different because we're going to add head bobbing. So as the player is running or walking or crouching, they're going to have a different kind of head bob moving back and forth. And this is critical to make the movement in the game feel legitimate. So this is our setup. We're going to have a head node with a sub node of eyes, and the sub node being the actual player camera. And the final thing we're going to need in this tutorial is a stand-up check. And what the stand-up check is it's going to be a raycast. And if we're crouching and we're underneath a wall, say in our sandbox here, our character should not be able to stand up if there's something above their head that they are going to splat into. So we're going to add a raycast on the character that's going to check, is there something currently above my head? So if we go back to our player, click on our player and hit Control A, and we're going to add a raycast 3D. So as you can see, there's this line pointing down. Now we don't want this line pointing down, we actually want it pointing up. So instead of being -1 meters, we want this to be 1 meter. So as you can see, that's now pointing up. But we actually want it to be 2 meters on the Y. Because what we will do is we're scanning the entire height of our character. And if the entire height of our character can stand up, there's nothing blocking it, then we will allow it to happen. So let's go ahead and rename this raycast stand up check. Now, before we hit the player script, there is actually one more thing we ought to do. The first thing we should do is hit Control S and save our player scene here in the player folder. The next thing we need to do is set up our keybinds. And the way we do that in Godot is under Project, Settings, and then under the Input Map, we need to add some actions. And these actions are going to be the various keys that the player is going to press. So we need to decide what our player is able to do in the game. So for the sake of this tutorial, the player is going to be able to move forward, the player can move backward, the player can move to their left and move to their right. The player will be able to jump. The player will be able to crouch. We also want to add a quit functionality so we can end the game. We are also going to need a primary and a secondary. Primary is going to be handled by our left click button, and the secondary is handled by the right click button. We will not touch those in this video, but we will get to them soon. We also want the quit button to be represented by escape, so that way when we are testing, all we have to do is hit escape to end the game. And obviously these actions are fairly self-explanatory. We use W for forward, S for backward, A for left, D for right. Jump is typically space, and crouch is typically control. Now the only one I'm missing is the sprint action. So let's add sprint. and sprint is handled by the shift button. So these are our key bindings, and we are going to use these in the player script to move our player around. All right, so let's actually program our player. So hit close, click on our player node, and attach a script. Now we're going to call this player.godot. We do want this to be in our player folder, and it can inherit from the character body 3D, and we don't need a template. We're going to go over everything in detail ourselves. So hit create, and we now have our player script. All right, so in our player script, we are going to want to have access to the various variables that represent the nodes on our player. So we are going to want to know about our head, we need to know about our eyes, and we need to know about the camera. We are also going to need to know about our collision shapes, so we're going to drag these in as well, and the stand-up check. Now, if you don't know how I'm doing this, I click on the node and I drag it in, but if you hold control, the entire variable will come in, and it will be the onReady variable, just like that. And onReady just means that when these nodes enter the scene tree, they are going to be assigned here. So right at the start of the game, or right at the point that they are put into the game, which for the sake of our player will be right at the beginning. Now, the next thing we need to define are the various movement variables, is what I'll call them. So let's create a comment and say movement variables. And these are going to hold the various speeds at which we walk, run, and crouch, and a few other things. So let's just go ahead and talk about it. Now, the first thing we need to know is how fast is the player going to walk. So I'm going to create a walking speed of, we'll say, 3 meters per second. I assume that's what that means. We are also going to need to know how fast we move when we sprint and how fast we move when we crouch. So I'm going to just copy and paste and change walking speed to sprinting speed and change the value to 5.0. And I'm going to change walking speed to crouching speed. That sounds good. And set that to 1.0. So when we're walking, we're moving medium speed. When we're sprinting, we're moving pretty much a lot faster, and when we're crouching, we're moving pretty much a lot slower. And the reason these are constants is because we don't want to change these speeds during gameplay, but we do want to change the speed of our character. So we need a variable for what the player's speed is right now. So we're just going to create a variable. We're going to call that current speed, and we're just going to set that to nothing because the player at the beginning of the game is going to be standing still. Now, this current speed can exist anywhere from 0 to 5. So if the player is standing still, they're not moving at all. If they're walking, we are going to update their speed to be 3.0. If they decide to crouch and walk, we're going to update their speed to 1.0. And if they're sprinting, they can be up to 5.0. So there are our walking, sprinting, crouching speeds. Now we need to get a little bit more complicated with the variables we need. Well, actually, before that, let's add in another variable called moving, which is going to be a Boolean, and that will be false. That will be necessary for our state machine, which we'll get into in a little bit. Now, the next variable we need is actually going to define how the player is giving input to the game. So this is going to be called var input dir, meaning direction, but that's going to be complicated to write out more than a few times. So we're just going to call it input dir, and this is going to be a vector2. And by default, we're just going to say that this is vector2 dot 0. Now, a vector2 is just two values kind of in a pair, so it'll look something like this. And so this vector2 input direction takes the two-dimensional movement given by the WASD keys, and we're going to use that to actually move the player in space. So, for instance, if we're moving forward, I think it's 1, 0, 0, 0. If we're moving backwards, it's -1, 0, 0. If we are moving left, I believe it's -1, and if we're moving right, it's 1. I could have those wrong. And then obviously you could have any combination of moving forward, left, forward, right, backward, left, etc. And we're going to use this input direction, as I've said, and we're going to map our 2D movement, which the player gives on the keyboard, to our 3-dimensional space. And the next variable we are going to need is our actual direction, which is represented by a vector3. And we're going to just initialize that to be vector3, 0. And similar to the vector2, this is just a set of 3 numbers where we are in world space with X, Y, and Z. The next thing we need to know is where we are going to put the camera when we crouch down, because obviously when we are standing, our camera will be here, but when we're crouching, our camera is going to be down here. So we need to define how far we want that to drop. So I'm going to create a variable, and I'm just going to call this, I'm actually going to make it a constant because this really shouldn't change. We're going to call it crouching depth, and we are going to say that this is, let's say, minus 0.65. We have to say that's equal to minus 0.65. And so if the camera here, let me look at the camera, this is going to be at 1.8 meters because the head is at 1.8 meters. So if the camera drops minus 0.65, you can see the camera is down here, closer to where the player is crouching. So I think that's a good spot for it. We can probably tinker with that later. And the final movement variable we need to define is how much the player is going to jump when they hit the space button. So once again, we don't really want to change how much the player can jump, so I'm going to make it a constant. We're going to call this jump velocity. And I think a good number for this is going to be 4, and we can tinker with that as well. So now that we've defined our movement variables, we should talk about the state machine. And a state machine does exactly as it is described. It is a machine, or a set of logic, to determine what state the player is in. So there are only so many states that the player can be in, and those can be represented by an enum, or an enumerable. So we are predefining what state the player can be in. So we're going to call this player state. So let's take a second and think about what state the player could be in at any given time given the specific movement variables. Well, the first state we could be in is what I'm going to call an idle stand. We're not giving any input, we're not moving, we're not jumping or falling. On the same account, the next one is going to be an idle crouch, meaning that we're just holding the control key down, but we're not moving at all. So then we have our 3 different kinds of movement where we are, let me go ahead and put on our caps lock, where we are crouching, where we are walking, and where we are sprinting. Now, depending on how you look at the state machine, there are basically 2 other states. One is that you're jumping up and you're in the process of going up, or you're falling down. Now, for this controller, you don't actually need to know that. The only thing we need to know is if we are not on the ground. And I've just called that air. Fix the comma. And so these are the states that our player can be in. They can be standing still, standing still, crouching, moving in 3 different ways, or they have jumped in the air at some point. And this should be enough to control and define what our player is up to at a given time. And we're going to need to keep track of what our player is in. So this is once again a variable which we call player state, and instead of being a basic type or a primitive type, we have defined what a player state is. So we can set that to be a player state, and by default when the game first starts, the player will be in a idle stand. And that is the basis of our state machine, and we'll get to messing around with that in a little bit. All right, so let's go ahead and set up the functions we're going to need. We're not going to write the logic for them just yet. I kind of just want to talk about what they're going to do. So the first one is the ready function, and the ready function is going to run once when the player enters the game. So this is a pretty important one, but it's not going to do that much for us, at least right off the bat. And I've made a mistake. The ready function doesn't actually have an event, so we can go ahead and get rid of that because it only runs once. What we do need the event for is the next function. I'm getting a bit ahead of myself, and that is the input function. Now, the input function runs whenever the player gives input to the game, and that will be defined by this input event object that we are going to call event. Once again, we are just going to not define the logic quite yet, but we are going to talk about it. So these functions aren't going to return anything, which is why they are void, but the input is going to handle our mouse movement, so the player looking around, and anything that is not defined by our physically moving in the world. So to define how we're going to physically move in the world, we are going to use the physics process. And the physics process is going to give us this delta value. And this delta value just represents the time between the frames. So if your game lags, if you don't have a great frame rate, the physics process provides you with this delta object, or this delta float, to define how you're going to update between frames. And we'll get into that in a little bit when we get to the actual movement code. And in the physics process, we are going to do a couple things, but I just want to add them in as comments. So I'm going to put the pound sign. We are going to want to update our player's state, and we're going to define that method later. And we're also going to want to update our camera. And these are going to be critical, and I like to separate them out so we can understand them better. So let's go back to our ready method. So back up here, you can see that the ready method is only going to run once when the player enters the game. So we only want to put something in here that's going to run once right at the start. And for us, that is setting the mouse mode to being captured. And what that means is, let's just go ahead and write this out. So set the mouse mode to input dot mouse mode captured. And that means that when we start the game, the cursor will not exist on my screen anymore. It will be purely in the game. And that prevents us from, losing where the cursor is somewhere off on our 4th or 5th monitor all the way over there. And that, I think, is all we're going to need in the ready function. So our mouse mode is captured, but what that's actually going to do is it's going to trap our cursor in the game, which is good. But until we build some kind of start menu or the ability to go to a pause menu, we need to be able to leave the game without having to Alt-Tab out. So in the input function, we're just going to add a check. So if input, and we're going to check if is action just pressed. And the action we're looking for was defined in our project settings, and I defined that as quit. And if we want to quit the game, we just do get tree dot quit. So as you can see, if I go to my project settings here, we define quit to be the escape key. So if I run the player scene, we just get a gray screen and my cursor is completely locked, but I should just be able to hit escape and we are out. So let's assume we don't want to quit the game. What else are we going to do in input? Now, input is actually going to handle our mouse movement, and our mouse movement is going to handle where our character's camera is moving in the world. So we're going to check if this event, which is this input event, and if this event is an input event mouse motion. So if we are moving the mouse, what do we want to do? Now this is going to be our first set of complicated logic, and I'm going to write it out and then I'm going to explain it after it is written out. So if we're moving the mouse, we want to rotate our entire character on the y-axis. We need that rotation to be in radians, and we need that to be defined by how much our mouse is moving in the x-axis, and multiply that by some kind of sensitivity. Let me think about this. Maybe 0.4 is a good sensitivity for me. In fact, I think this is probably a variable we should define outside of this function. So let's come up here and we're going to say var mouse sensitivity, which is going to be a float. And instead of 0.4, I think I want it to be 0.2. Make that an equal sign. That'll probably work a lot better. And instead of having that there, we'll put our mouse sensitivity there and make sure we get this right. All right, that looks correct to me. All right, so what is this line actually saying? So the event is our mouse moving, right? So as you can see, my cursor is moving, and we want that movement relative to the x-axis. So that means we don't care how much we're moving up and down. Sorry, we don't care how much we're moving up and down. How much has the mouse moved left and right? Now we want to multiply that by mouse sensitivity because obviously players play on a different sensitivity. You want to be able to customize that and put it in a pause menu. So this value is going to be a degree. So if you think a circle has 360 degrees, that's the degree. Now the rotate y function needs it in a radian, which is a different measurement of rotation. So that's how we get that value. Now, what does rotate y mean? Rotate y means just as you think it does. It means we are, let me go to the player scene, we are rotating on the y-axis. Now, it's very critical to understand that this rotate y is rotating the entire player. And we only want to do that on the y-axis. And we're going to get to this in a second, but the head is what we want to move on the x-axis. We don't want the player entire to rotate on the x-axis, otherwise you're going to get some funky logic here. However, if the player turns to their left and then presumably will move forward, we want the entire player to turn as well. So that's what we're doing. We're rotating the entire player on the y-axis defined by how much we moved our mouse to the left or right. And so as I said, we're going to want to do the same for the head of the player. So what do we want to do? We want to rotate X, but we don't want to rotate X on the player, which is what this script is on. We want to do it on the head. And the reason we can do it on the head is because we dragged in the head node here earlier. So how are we going to rotate X? Well, we can go ahead and copy and paste this same logic, but the difference is instead of relative to our X movement, our left and right movement on the mouse, we want it relative to our Y because we want to go up and down. Now this is a little confusing because we're defining our X movement to our Y rotation and our Y movement to our X rotation. However, you can see this most clearly in 3D. We want to move left and right to move our character left and right, and we want to move up and down so that way we can move it on the head up and down. I hope that makes sense. So now this logic is actually incomplete, but I want to demonstrate to you why we're doing this next line. So let's go to the sandbox, let's go into 3D mode, and I'm going to open up my player folder and drag my player into the game. So as you can see, he's in the ground here, I think. So let's go ahead and drag him up. We'll go ahead and save this, and we'll see what happens when we run this scene. So as you can see, we don't have any lighting, but if I move my mouse up and down, I'm looking up and down, and if I move left and right, I can move left and right. But there's going to be a problem. If I look all the way down and just keep going, I can infinitely flip my camera, which is not good. We actually want to clamp the value so that way we are not looking more than, roughly at our feet and no more than roughly looking at the sky. So the first thing I want to do is I want to add our sun and our environment to scene, and that way when we run the game it doesn't look like whatever that just was. But once again, we need to clamp these values. So let's go back into our player and go back into our player script. And the reason I said clamp is because that's actually the function we're going to use. So we don't want our head, which is the value we're rotating. We don't want that rotation, that specific X rotation. We don't want that to go more than below our feet and backwards above our head, so that way we're looking like the character from The Exorcist. So that is going to be a clamp function. Now the clamp function takes in 3 values. What are we currently at and what are we affecting? So we're affecting the head rotation at X, and what values do we want it between? So once again, we need this to be in radians, which is easier math for the system, but not necessarily easier math for us. So we need to define 2 values that we're going to clamp between. So the first value is going to be roughly minus 85 degrees, which is, if you think of a 90 degree angle straight down, you're going to look just at your feet, and 85 degrees up. So let's go ahead and run this and see what that looks like. So as you can see, when we look down, I can't look any more than down at my feet. And when I look up, I can't look up any more than at that sun. So now we have a mouse movement that feels fluid, if, a little stiff, but I think it works. All right, so now that we can look around, let's try to get our player up and moving. So go ahead and hit escape, and let's talk about our physics process. So before we get our player moving left, right, and center, I think the easiest form of logic we can set up is actually the jump and the fall logic. So let's go ahead and get rid of this return statement. And let's add an if and an else statement. Now, there's 2 situations when you're handling jumping. There's if you've jumped and you're going up, or if you've reached the peak of your jump and you're going down. Now, we're going to have to do this a little backwards because we're going to check first if we are not is on floor. And so this will return true. This is on floor will return true if you're on the floor. So if we're not on the floor, let's go ahead and put a comment here and just say we're falling. And then this is where we would put our falling logic. I'm just going to put return for now. However, this else, I'm going to put a little comment here that says we're jumping. So if we're on the floor, we are allowed to jump. So how are we going to define if we can jump or not? Well, the first thing we need to check is if the player has pressed the jump button, which is just as we did with the quit button. We're going to check if input dot is action just pressed, and this one is jump. So at this point, the player is on the floor and they've just pressed the jump button. So now let's have the player jump. So once again, this script is on the player themselves. So all we need to do is set the player's velocity.y equal to the jump velocity that we defined up here. So now the player should be able to jump. The problem with this is we are only ever setting the velocity.y here. We actually need to have the player fall down at some point. So let's go back up to here. If the player's not on the floor, we want to slowly have them come back down to earth. So what we want to do is we want to check if the player's velocity.y is greater than or equal to 0. And we'll touch on this in a second. Now, if it is, we want our velocity in general, not just .y, our velocity in general, we want to set it to what our gravity value is, which in this case will be 9.8, and we're going to multiply that by our delta value. And if our velocity.y is not greater than 0, we're going to do the exact same calculation, and we're going to multiply it by 2.0. And so what does this block of logic mean? Well, if our velocity.y is greater than 0, that means it's a positive number. And if it's a positive number, that means the player is jumping upwards. If our velocity.y is less than 0, if it's negative, that means that the player is falling down. So this little extra snippet here, this 2.0, it makes the jumping feel a little snappier. Because if you jump up and fall down at the same rate, it feels like the player is a little floaty. So let me go ahead and see if we can demonstrate this now. Oh, and I'm just realizing that we need to add a move and slide function at the very end of this, and that just tells Godot to take in all of our velocity account and actually perform the physics calculation. So now let's go ahead and see if we can run this and see what happens. We fall through the floor. So to fix falling through the floor, this was actually something we missed out when we built the sandbox. All of our CSG bodies here do not have a collision shape by default. You have to click Use Collision. So let's go to our floor and click Use Collision in the inspector. Go to Wall, Use Collision, and Crouch Check, Use Collision. So let's go ahead and run this again and see what happens. Here we go. Let's click Start. And we jump and we fall. And as you can see, we kind of slam to the ground, and that feels a little better. For the sake of demonstration, I'm going to go ahead and remove that 2.0. So let's go into the script and just delete that 2.0. Press start and run again. So as you can see, that feels a little floaty. That doesn't feel like how someone would actually jump. So I think that 2.0 is necessary because the player just feels like they're actually being affected by gravity. But as you can see, we can still not move around. So let's go ahead and figure out how we're going to do that. So back in our player script, we are going to go to here, and I'm just going to write this as the movement logic. And now we're going to have to talk about the two variables, our input direction and our actual direction. So in our movement logic, we need to know what our input direction is. Now, the input direction is going to be defined by, once again, input. We are going to get a vector because, once again, this is a vector 2. And we want our vector to be defined by our various movements. Our left, our right, our, let's go forward, and our backward. So what this means is that this vector is going to be stored based on if we're clicking WASD. And we can clearly see this if I just print out our input direction, excuse me. So in the bottom corner here of the console, sorry about that, look in the bottom left-hand corner and let me make sure that that is outputting. So if I hit play, you see 0, 0. I'm going to hold down W, so we have -1. If I hit left, we have -1 in the X category. If I hit S, we have 1 in the Y category. And if I hit D, we have 1 in the X category. Now, as you can see, let's say I'm a player and I'm moving around. All of those numbers can get all kinds of jumbled. But the important part is we have two values representing our movement in 2D space. Now we need to apply that to 3D space. So to apply that in 3D space, we obviously need a third vector to define our up and down movement. So our variable that we created was our direction, which represents the direction we're moving in 3D space. Now, this is going to be defined by a few things, and I'm going to, once again, write out the whole line and explain what I'm doing when I'm done. So we are going to use the lerp function, and we are going to interpolate from our current direction to the transform dot basis times vector 3, and this vector 3 is made up of our input direction dot x, just 0, and input direction dot y. We are also going to call normalized on this, and after normalized we're going to add a comma and say delta times 10.0. So what is this line actually telling us? So lerp is short for interpolate. Now, when we move, we don't want to just snap like we're on a grid in our movement. We want it to feel fluid. If the player starts sprinting, they should not immediately be at sprint speed. They should kind of take a second to get there. And same if they go immediately from sprinting to crouching, they should slow down first, right? So interpolate makes sure that movement is really smooth. So what interpolate does is it takes it from our current spot to the spot we're trying to go. Now, what is this spot we're trying to go here? So let's start with this vector 3. Now, we have our input direction x, which once again is our forward and backward movement, and we have the input direction y, which is our left and right movement. I might have gotten them switched, but it doesn't really matter. In the middle here, we have a 0. Now, this is going to be confusing again because we have a vector 2, which is an xy, and a vector 3, which is an xyz. Now, if you think about it as the input directory having an x and a z, so let's say our, not directory, input direction, excuse me. If our input direction is 1, 0, 0, 0, what this should really represent is 1, 0, 0, 0, 0, 0. And why is that? Well, you see this logic here that's handling our Y movement, our up and down movement, is actually just being handled by our jump code. So we never want our direction here to really be affected by anything that we're doing on the keyboard except for jumping. So that stays as a 0. So our X and our Z, where we are in 3D space, are defined by our input directory. Now this is probably better represented in 3D space here. So this red axis here is our X, and this blue axis here is our Z. So if our player hits A or D to move left or right, they do this. And if they hit W or S, they're actually moving on the Z axis, even though the input directory defines this as the Y. So that's kind of the confusion with that. But this should work just fine to get our player moving. So now that we know our direction, what are we going to do about it? Well, just like the jump, we actually need to manually change our velocity. So we're going to check if direction, and this just means if we have any direction. So if the player is standing still or crouched, we don't want to bother doing any kind of this logic. That being said, if we are no longer inputting anything while we were moving, we want the player to slowly come to a stop. So let's deal with this first one. If we are trying to move, what are we going to do about it? We're going to change our velocity in the X direction, and we want it to be in the X direction and multiplied by our current speed. And current speed is going to be represented by if we're walking, sprinting, or crouching. And you can go ahead and just copy and paste this line down and change these to Z. So we have our velocity in two directions in three-dimensional space handled by whether or not we are walking, crouching, or sprinting. So let's just say in the previous action we were moving, we were sprinting, but now we don't want to move anymore. Well, that means we don't have a direction because the player is not actually inputting any data to the game via the keyboard. So what do we want to do? Well, we still want to define our velocities, but how are we going to define them? The way we're going to define them is using this function that is move toward. Now, move toward takes in three values. The first one is where we are moving from, and we want to move from our current velocity, and we want to move towards 0, right? Because this is the situation where the player wants to stop moving. So if we are walking forward and we stop, we don't want to just hit the stop and immediately stop moving. We want to slow ourselves down because it feels much smoother. But how much are we going to actually do that by? Well, we want to do it by our current speed. And the reason why we want to do that is if we're sprinting, we want to come to a stop slower than if we were crouching. And that's how we're going to define that here. And of course, once again, you can go ahead and copy and paste this line and make sure that we are doing the same to our Z velocity. Now, before we run this, there's going to be a slight problem. Current speed here we defined as being 0.0, which would be fine once we have the state machine up and running. But for the state of testing, I'm just going to set this to the walking speed. So let's go ahead and click Start. And as you can see, the player is able to move, and it looks kind of stale. You know, we're able to move, we're able to look around, and we're walking in the direction that we're moving, but it just doesn't feel as crisp. And the other thing we can't do is we can't hold shift and run, and we can't hold crouch and crouch. So let's see what we can do about doing that. So before we do any kind of movement code to get the sprinting and the crouching working, what we're actually going to need to do is set up our state machine. So go ahead and uncomment your update player state function, or add it if you didn't before. And as you can see, our player state was defined at being at an idle stand. However, even if we're moving, that never would have been updated because this is the only place it exists. So let's go ahead and make sure our player state is in a good position. So we're going to create a function, and we're going to call update player state. And update player state doesn't need any arguments because we're going to know everything we need to know. So before, we created a Boolean called moving, and that just defines whether or not the player is moving in any capacity. So let's go ahead and check if the player is moving. So how do we define if the player is moving? Well, we define if the player is moving based on the input direction. And if that is not equal to vector2 dot 0, then the player is moving. So how does this make sense? Let me hit enter a few times so that way this is at the center of our screen. So if the player has an input direction, that means they're trying to move forward, backward, left, or right. If it's 0, that means they're not touching the keyboard at all and they don't want to be moving anymore. So now that we know if the player is moving, we next need to check if the player is in the air, meaning if they have jumped or not. And how do we do that? Well, it's the exact same way we did it in the physics process. We check if not is on floor. And so if the player is not on the floor, that means they are in the air. So set our player state equal to player state dot air. And there's our first state that the player can be in. So let's say they're not in the air, but they are moving in some capacity. Well, the first situation they could be in is that they could be crouching. But to do that, we need to check if an action is being pressed and if the action is crouch. Now in my game, I like to have crouch being held. If you have a single touch crouch where maybe you just press C, this would be is action just pressed. However, if the player is holding crouch, then they are in a crouch position. However, we defined two different crouch states, an idle crouch or a moving crouch. So very simply, all we need to do is check if the player is moving. If the player is not moving, then the player state is in an idle crouch. If the player is moving, then the player state is in crouching. So now we can know if the player is in the air or if the player is crouching in any capacity. So let's say the player is not crouching, but they are moving. Remember, we would know if we are moving here. So if the player is not crouching, but they are moving, we need to check something else. The first thing we need to check is if the player is able to stand up. Now this is important because there's a possibility on the previous frame, the player was crouching, they were holding crouch, and they were underneath an object. Let's go back to the sandbox. They were crouching underneath an object that prevented them from standing up. So we need to know if the player is able to stand up here. Now that's critical because we don't want to say the player is still crouching if they are able to get out from under this. So how do we know if the player is able to stand up? Well, we added our standing check although we may not have dragged it into the scene. Oh, no, we did. Let's go ahead and take our stand-up check. So if our stand-up check is colliding, and all is colliding says is if the raycast here is hitting something. So if I go into my sandbox here, and I grab my player, and I drag them here, you can probably see that the raycast would hit that wall there. So if it is colliding, we want to keep the player crouched. We don't want them to stand up, and we want to keep their player state as crouching. However, if that raycast is no longer colliding, we're going to want our player to stand up. So let's go ahead and go back into our script. So at this point, the player is moving, and they are able to stand up. So we need to check a few more cases. So the simple one is if the player is not moving, then the player state is that the player is now just standing. So if the player is not jumping, but they're not crouching, but they're just standing, and they're not moving, they're just standing. The next condition is if, elif, the player is holding down the sprint button. So if the player is holding down the sprint button, well, then quite obviously, the player is sprinting. And then finally, if the player can stand up, they're not crouched, but they are on the floor, and they are moving, the only possible state left is for the player to be walking. So I'll go back through this one more time. If the player is in the air, they're in the air. But let's say they're on the ground. If they're holding down crouch, they're either idle crouching or they're crouching while moving, and that's determined whether or not they're moving. But let's say they're not crouched and they're on the ground. Well, we need to make sure that they're not colliding with anything, because if they are colliding with something while they are crouched, we want to ensure that they stay crouched. But let's say they're out in the middle of the open air. Then we only need to know if they're moving. So if they're not moving, they're idle standing. And if they're sprinting, well, then they're sprinting. And the only possible option left is walking. So that is our player state machine. And I think we'll end this one here. In the next episode, I will update the player collision shape, so that way the player can actually shrink and grow and get in between the little nooks and crannies of our sandbox level. And I will also update the movement code, as well as adding in some head bobbing, so that way the player's character feels a little bit more alive.